are you ready?
Can you tell me? No, I think they're okay. Just get out.
Yes, okay, fine.
Ready?
Yes, we are.
Okay.
Hello, so we are A.Em Alpha team. We'll get there live. And the project we're working on is space wearables, and we're contributing to the safety of the future space exploration. So the space is a dangerous environment for human humanity, and the vulnerability of the International Space Station demonstrates why. Fires in microgravity behave differently, and confined space make it particularly dangerous for human beings to be in space. The space debris can penetrate and make massive dents in the antibody of the International Space Station and penetrate mesh of Kevlar, which could lead to punctures and rapid differentiation of the pressurized environment. So if we take a hole which is 5 by 5 line equation, this equation, it will take 37 minutes for the pressure to drop to the critically dangerous levels, and will take 40 minutes to get into the spacesuit. And the chemical contamination, again, in a confined environment is very difficult to get away from. Naturally, there are safety measures and precautions available in the ISS. So the key ones are the spacesuits, 20 kilograms, $10 million, 40 minutes to get in, and at the moment is the Soyuz escape capsule, which doesn't really have enough space for a person in a suit. So these are great and invaluable. However, the person that gets to these has to be conscious and functional. And this is where the idea for our project comes into place. We are proposing to combine the existing safety measures, safety kits available on ISS, in diving and in mining, and combine them with sensors and microprocessors to design a smarter way of dealing with emergencies. And our idea is the first response mask that allows to deal with the onset of the atmosphere emergency. So I'm going to quickly run through the prototype design as sketched, quickly because there will be a live demonstration of the more important component, which is actually currently not included in most of the first response mask, which is sensory part of the safety kit. So we don't just want to keep person alive for longer, we want to enable person to communicate and to navigate through space in the critical situations. So we are going to very quickly imagine emergency. We do not have the actual prototype, it was very tricky to deal with, but bear with me and imagine critical situation. The person gets to prototype, gets the helmet. By pulling the straps on, the seal is broken, which triggers the switch, which sends the signal to the control center, indicating that the helmet was triggered. The seal between the neck and the stitch is made of the closed cell foam, which expands with the drop in the gravity, in the pressure, keeping the tighter seal. The oxygen is supplied in the way of the air canister, and the screen, the goggle screen, allows the detection, monitoring of the live detectors, and enables you to see your surrounding environment, that information being fed by the sensors. The fabric itself, the helmet itself, is made of compression fabric. Sorry, wait, what is? Okay, compression fabric, and there's a camera in navigation. So when we trigger the seal, and that's what we've been working on. We've been actually working on the sensor itself. So we trigger the seal, and
so this is what we've been working on this weekend. So this is a prototype using some sensors. We've got pressure and temperature atmospheric sensors, a simulated oxygen canister which is running out. If you want to refill that.
Yeah, we can refill that.
That's good. And a heart rate sensor.
which is
Head-up display as well.
So this is the head display as well. So this is what you might see as the wearer. You've got a transparent screen up here. I'm just going to update in a second with the information. There we go. That tells you the temperature and the pressure and how much oxygen you've got left, which is the key information you want to know. And then for the control centre, you'll be able to see all the heart rate in addition, as well as any other masks that are enabled and their location on the space station.
you'll probably be able to see my heart rate going up. This is a critical situation for me. There we go. There we go. That down. Okay.
So the temperature should come down a little bit,
The
isn't it?
temperature is going up because it's been sitting in there.
Yeah, it's got quite warm in the room. So there we go. So when the heart rate goes over a set value, it triggers a warning and flashes your
And it
clock.
shows where you are.
Show that you're in distress. And we've got to stop. There we go.
There's much more.
We have loads of information and research that we've done and data on the background of this, so ask questions if you have any.
That's true. That's the true heart rate.
There you go, it's put it back now. You've got it back on now.
Okay.
Any questions?
What's the most interesting thing that your product does that you haven't told us about?
Communication.
Communication. Yeah. So we'd actually use the existing radios that they have in spacesuits on the ISS now to communicate between these. And the data would be packaged up and piggybacked on that on a mesh network, so that all the helmets would share all their data between them. So if communications are lost with the base, they all have all the information. Only one of them needs to re-establish communications for the control center to get an update. That's probably the single most interesting bit, is it?
How are you monitoring the location?
That's from one of the sensors that we haven't included in the prototype. So that will be a camera in the helmet which can see infrared beacons. Just little LED controls and batteries, tiny packages dotted around the ISS, flashing a sort of barcode. So if even if there's no other power and it's in the dark and you can't see where you are, your helmet can clock 3 locations of those and triangulate your position, so that it can tell you where to go perhaps, and also obviously it can tell the control where you are.
On the glass technology you are using, because you've got the display on the glass, is it already existing or is it?
Yes, it is, yes.
If you go back to, so quite a lot of things that were shown with the prototype, I had to press forward.
Yeah, control the...
I don't think you can zoom in anymore. Oh no, you can. You can go forward.
Oh, yeah.
Yeah, so that's closed up. So this is the transparent electroluminescent display. There is a Lumia company that they're currently doing the transparent.
And they look pretty much like the mock-up here of the head display. That's the sort of thing you get. It's transparent. I think it's like a polymer thing with a thin film in the middle that luminesces. So it's very low power, very robust, works in vacuum. It's all sort of, yeah, super cool.
It's taken me 2 days to work the exact place out of my neck, but the heartbeat sensors it works, but you should be in business down there. If I jump up and down, it should be
Doing that.
It's going down. No, it's going down. There we go.
And what more is the oxygen supply?
Yeah, the oxygen supply is
It's an emergency. And it's not a perfect seal, but
Nicholas, what should-
it's enough to keep the pressure until you get, and when you get to the emergency, which you can see on your screen display, it tells you when you need to do something about your oxygen. A small canister can be dotted around and can be replaced, refilled. Well, now we can simulate it by unplugging and plugging it back, and the simulation of removal of the kind of partition.
Pumping the canister over, yeah.
Yes.
So the mask will be pressurised as spacesuits are with pure oxygen to about 300 millibars, so you don't need full air, you can actually breathe pure oxygen at the lower temperature, lower pressure. Makes the materials a bit easier to work with as well. Rubber bands would actually more or less hold the pressure in.
I'll let it go down.
What does A.Em alpha do?
So
Atmosphere emergency.
an alpha because it's in
Alpha
alpha.
because it's
An alpha. Okay, thank you.
And one final question. In case of fire, and there is smoke everywhere, how do you know where to go?
the control, that's the communication. So the idea is the infrared camera becomes
Yeah.
the location of the angle position.
A broadband infrared, like you'd see through most haze and smoke and things. Also, obviously these are astronauts, so they have some emergency training now.
Also, if you've got location data here and there's a control centre like on the ground somewhere and they know where you are and you're on radio link,
But
and they see you know, wandering around, if there's sort of, I don't know, infrared sensors in there or something which should locate your position, then, you know, this just helps somebody else to help you as well.
You say you use infrared, but if there is a fire,
Oh, that is infrared, yeah.
at the end, if you got smoke because of
Oh,
fire,
for smoke, yeah.
and you are using only infrared camera for position,
You could use something like parking sensors, that type of technology. In fact, you could use multiple of them and just kind of get
Fire might confuse the signal because